Today we are going to learn about mastering k-means clustering in Scikit-learn. We will dive into implementing and optimizing k-means clustering effectively using Scikit-learn, perfecting your skills in data analysis and machine learning. Welcome to our video on mastering k-means clustering in Scikit-learn. In this session, we'll unravel the fundamentals of k-means clustering, an essential algorithm for clustering tasks in data analysis. We'll explore its pivotal role in machine learning, where it helps reveal patterns and insights from your data sets. By the end of this video, you'll be equipped with the skills to apply k-means to real-world datasets and optimize its performance. So, let's dive into the world of clustering and see how you can leverage this powerful tool in your data analysis toolkit. K-means clustering is an iterative algorithm that divides a dataset into k-distinct, non-overlapping subgroups. Each data point belongs to the cluster with the nearest mean, serving as a prototype of the cluster. The algorithm aims to minimize the variance within each cluster, effectively grouping similar data points together. Imagine you have a scatter plot of data points. K-means will help you identify groups by placing centroids strategically. It's like finding the gravitational centers of galaxies in the vast universe of your data. This process continues iteratively, recalculating centroids and reassigning data points until a stable configuration is reached. K-means is widely used in market segmentation, image compression, and more, making it a valuable tool in any data scientist's arsenal. The k-means algorithm is celebrated for its simplicity and scalability, making it suitable for handling large datasets efficiently. It is relatively fast compared to other clustering algorithms due to its straightforward approach. However, it isn't without limitations. K-means is sensitive to outliers, as they can skew the results significantly, affecting the cluster centroids. Another critical challenge is choosing the right number of clusters, k, which can vary depending on the data and the desired level of granularity. Additionally, k-means assumes that clusters are spherical and equally sized, which might not always hold true in real-world datasets. Despite these challenges, k-means remains a popular choice due to its ease of implementation and effectiveness in many scenarios.
Before diving into implementation, it's crucial to set up your environment correctly. First, ensure you have Python installed on your machine. You can download it from the official Python website. Once installed, use pip, Python's package installer, to install Scikit-learn. Simply run pip install Scikit-learn in your command prompt or terminal. Alongside Scikit-learn, you might also want to install other essential libraries like NumPy and Matplotlib for data manipulation and visualization. After installation, verify it by importing Scikit-learn in a Python shell or script. This setup forms the backbone of our implementation journey, ensuring we have all the tools ready for effective clustering. Once the environment is set, the next step is loading and preparing your dataset. Choose a dataset relevant to your problem statement. This could be from open datasets available online or your proprietary data. Start by cleaning the data, which involves removing or imputing missing values and handling any inconsistencies. Feature scaling is another vital step, as k-means is sensitive to the scale of the data. Use techniques like standard scalar or min-max scalar from Scikit-learn to normalize your features. Proper data preparation ensures that the k-means algorithm works effectively, enhancing the accuracy of your clustering results.
Choosing the right number of clusters, k, is a crucial step in k-means clustering. A common technique is the elbow method, which involves plotting the variance explained as a function of the number of clusters and looking for an e-point. This point indicates a good value for k where additional clusters don't vastly improve the model. Another approach is the silhouette score, which measures how similar a data point is to its cluster compared to other clusters. These methods, combined with visual inspections of clustering results, help determine an optimal k, ensuring meaningful and insightful clustering. Now that we're prepared, let's implement k-means using Scikit-learn. Start by importing the k-means class from scikit-learn.cluster. Create an instance of k-means, specifying the number of clusters. Fit the model to your dataset using the fit method. Once the model is trained, use predict to assign cluster labels to your data points. Visualize the clustering results using libraries like Matplotlib to gain insights into the data distribution. This step-by-step process, accompanied by real code examples, will empower you to implement k-means efficiently, transforming abstract concepts into tangible results. Evaluating clustering results is crucial to ensure the effectiveness of your model. Inertia, or within cluster sum of squares, WCSS, measures how tightly the clusters are packed. A lower inertia indicates better clustering. Silhouette analysis is another robust method to evaluate the quality of your clusters, offering insights into how well separated and cohesive they are. Besides numerical metrics, visualize the clusters to identify areas of improvement. This comprehensive evaluation helps refine your model, guiding adjustments in the number of clusters, feature selection, or data pre-processing to enhance clustering performance. Optimization is key to mastering k-means clustering. Start by experimenting with different initialization techniques like k-means++ for better centroid placement. Adjust algorithm parameters such as the number of initializations to improve robustness. Address the sensitivity to outliers by removing or transforming extreme values. Dimensionality reduction techniques like PCA can also enhance performance by reducing noise and computational cost. Iteratively refine your model, considering these factors to optimize clustering results, turning k-means into a powerful, efficient tool for your data analysis tasks.
As we conclude, let's recap the journey of mastering k-means clustering. We've explored its fundamentals, implementation, and optimization using Scikit-learn. Remember, practice is crucial. Apply these concepts to diverse datasets to gain proficiency. K-means is not just an algorithm but a gateway to discovering patterns in your data. Continue learning and exploring advanced clustering techniques to expand your skill set. For further study, numerous resources and communities are available online to support your learning journey. Thank you for joining us, and happy clustering.